All right. So if you're testing different surfaces, like here's an example.
Dad, a broken orb.
I'm gonna measure these not with my app. If I was using a phone app, I would just put it right here and have my bubble level to tell me the angle at which it slips. Okay. If you're using a paper protractor, you're going to get it to the point where it slips, like right there. Then you're gonna come in here. Now, I printed this off. I kind of had to fold it. And I'm gonna put it right here, and I'm gonna estimate. I'd say that's 10, 20, not quite 30. I'll say 27. So that was 27 degrees to get this surface. Now this is a glass jar. Linus says there's an Orbeez in there too.
A broken one.
A broken Orbeez. Okay, it's a big giant Orbeez. And it's glass container sliding on wood surface. So that's one combination you could test. I got 27 degrees on that. And then Linus, let's test this one. Excuse me, buddy. Okay, so now I've just taken my flat surface and I've just changed it. It's a fabric, so it's a towel. So a kitchen towel, we'll say kitchen towel and glass. So you could make your hypothesis and then test it. Is it gonna be greater than 27 or less than 27 before it slips? And so we can go, I actually think it's a little grippier. Here we go. I'd say right about there. So I can measure that, and I estimate that that would be about 41 degrees. Okay, so from here, 10, 20, 30, 40, and it was 41. Thanks, Linus. Okay, and then I think at the end of the lab, if I remember the questions, after you guys have found the surfaces that produce the greatest angle and the shallowest angle, oh, careful. One of the questions I asked was,
Needs those scissors.
oh, here, why don't you take them? You can cut this paper while I finish this video. Okay. I think I asked the question, do you think mass will affect the angle at which it slips? So to test that, I'm gonna go over here and dump out the Orbeez. Or here, let's see. I don't wanna upset Linus. I've got a empty container. So this has less mass than before. The other one was, I think, 41. So let's see what we can do. So my estimation says that less mass, now it's only about 36 or 37. Maybe, and you can confirm this, maybe less mass will result in, let's say, a shallower angle, but maybe that's less friction. So mass might have something to do with it. So that might be a hint to how you can win the competition. You need to confirm that result and then try. And then the other thing I wanted you to test was something called kinetic friction. Nice work, Linus. Okay, we can test paper on wood slips. Oh, it takes a pretty steep angle for paper. We can even test, right, paper. Here, I could tape the paper to the glass and then try and slide it. But okay, my other thing I wanted you to investigate was kinetic friction. Now, this, as you tilt it up, this is not moving. So right here, this is not moving. So right now, static friction is actually holding it in place. Gravity's trying to pull it down, right? There's a ramp. Gravity's pulling this way, but because of the ramp, it's kind of trying to slide down. Okay, static friction is holding this. Okay, when this starts slipping, thank you, sir. When this starts slipping, there's something at play called kinetic friction. So here, Linus, hang on a second.
That's how I want the movie to be.
All right. Okay, so here static friction is holding it in place. I'm gonna get to my angle, and then you can actually test kinetic friction. Kinetic friction is called sliding friction.
One day.
Will this slide if I give it a little head start? And you'll see I can be at a less steep angle. Just a sec, let me finish this. You can be at a less steep angle and start it moving, and it'll slide. So I think one of the final questions is asking you about kinetic friction. So compare your maximum static angle, right, where it can be before it starts slipping. Compare that to an angle that's slightly less, that maybe you can get kinetic friction to work. So kinetic friction is called sliding friction. Static friction is friction that involves no motion. It's just being held in place. Okay, so see what you can find out. We will have a little recognition and some extra credit points for the people who can get the surfaces that produce the greatest angle and the surfaces that produce the smallest angle. So good luck.